Use the improved Euler's method to obtain a 4-decimal approximation of the indicated value, that being y of 0.5, for the differential equation y prime equals 4x minus 2y, and the initial condition y of 0 is equal to 2. We're first going to use a step size of h equals 1/10, and then a step size of h equals 5/100. We're going to see what the mechanics look like a little bit by hand, but then I'm going to jump to using Excel. First, using a step size of 0.1, and the initial condition tells us that x naught is equal to 0 and y naught is equal to 2. Using Euler's method from our previous lesson, y sub 1 star is equal to y sub 0, so 2, plus our step size, 0.1, times f of x naught, y naught. That means 4 times 0 minus 2 times 2. We get y sub 1 star is equal to 1.6. x1 is equal to 1/10. y1 is equal to y sub 0 plus step size times an average of two slopes. So I'm going to write it down as 0.1 divided by 2 times f of x naught, y naught. So 4 times 0 minus 2 times 2 plus f of x1, y1 star. That's 4 times 0.1 minus 2 times 1.6, where 1.6 was from Euler's method. That gives us a value for y1 of 1.66. What happens next is we use that to find y2 star. y2 star is going to be previous y value, so 1.66, plus step size times 4x1 minus 2y1. So that's 4 times 0.1 minus 2 times 1.66. That will go into the formula that we use to find y sub 2, and so on. I'm setting up our Excel spreadsheet here. I have our step size of 0.1, x sub n, y sub n, and f of x sub n, y sub n for Euler's method. For our improved Euler's method, we additionally need y sub n plus 1 star and f of x sub n plus 1 comma y star sub n plus 1. Our initial condition told us that when x was 0, y was 2. And then to generate new x values, I'm going to say that our x sub n plus 1 is equal to our previous x sub n plus the step size 0.1. Don't forget absolute referencing. On a Mac, it's Command T. Windows, it's Shift F4. If you got another system, I don't know, look up absolute referencing or just type in $signs. Dragging in that formula gets me all the way down to x equals 0.5. f of x sub n, y sub n is equal to 4x minus 2y, and then y sub n plus 1 star is using Euler's formula. So this is equal to previous y value plus the step size, absolute referencing, times our f of x sub n, y sub n. We get that 1.6 that we saw before. F of x sub n, y sub n star is equal to 4 times x sub n plus 1, I meant to say, minus 2 times y sub n plus 1 star. And we get negative 2.8, that's fine. Our new y value is equal to our previous y value plus the step size, absolute reference, divided by 2, times the sum of f of x sub n, y sub n, and f of x sub n plus 1, y sub n plus 1 star, and we get that 1.66 that we saw before. I'm going to drag all these formulas down, and we'll have an approximation for y of 0.5. It's about 1.1122. Now I'm going to do all that same stuff again with a new step size, and then we'll start to look at error. So I'm going to change the step size to 0.05, and then I need new formulas. I can just drag all these down to get to where I have a new approximation for y of 0.5, which is 1.1056. Now that we have those approximations, let's look at the error analysis. For this, I'm going to copy our values of x sub n, y sub n. When I paste, I'm going to use values and not formulas. And then we need y actual. Well, in order to find the actual value, we have to solve the differential equation. Folks, you got several techniques here. We can consider this as linear. We can use an integrating factor mu, or we can use an auxiliary equation. We've got Laplace transforms. All of these are valid techniques. In fact, it would be a good idea for you to pause it now and solve the equation. I'm going to proceed using an auxiliary equation. Y prime plus 2y is equal to 4x is going to give me an m value of -2. That gives me a complementary solution of y sub c is ce to the -2x. And then the input function on the right-hand side is 4x, that's linear. And so y sub p is equal to ax plus b, and I'm using undetermined coefficients. You could go ahead and pause it now and work this out. I'll even stall for a moment. Okay, I'm done stalling. A is going to turn out to be 2, and b is -1. So y is equal to ce to the -2x plus 2x minus 1. You can even pause now and bring in the initial condition if you wanted. Using the initial condition, that y of 0 is equal to 2, I'm going to get that c is equal to 3. And finally have the analytic solution, y is equal to 3e to the -2x plus 2x minus 1. All right, now we've got our actual solution, and so we can say that y actual is equal to 3 times the exponential function with an exponent of -2x, close that, plus 2 times x minus 1. Of course, the first actual value is spot on. In addition to the actual value, I want the absolute error, and that's equal to the absolute value of our actual value minus the estimate there, the approximate value. It doesn't matter which order we subtract because we used the absolute value. I also want a percent relative error, and that's going to equal the absolute error divided by the actual value. And then grab those, drag that down, and I said percent relative error, so let me convert these to percents, and then give me some more decimal places. All right. So when the step size is 0.1, our approximation for y of 0.5 is 1.1122 with a relative error of about 0.78%. Now I'm going to do all that same stuff for the step size that we had of 0.05. For that though, I need to use our new table here, and I'm going to input, paste it as values, and then drag this down here. And this is what this has been about. Using a step size of 0.05, we now have an approximation of y of 0.5, which is 1.1056. And the relative error, the percent relative error, is like 0.18%. I've dropped screenshots of that spreadsheet work into these notes here because I want to point something out here. Those errors were about 0.78% and then 0.18%. So we're going to note that when h is cut in half, so h becomes 1/2 h, that gives an error that gets cut by approximately 1/4. That's an illustration that error is big O h squared. It's not exactly 1/4, right? I mean, in fact, it's actually less than 1/4 because the 0.78 would have to be 0.72 in order for 0.18 to be 1/4 of it, but it's in the neighborhood.